Oh.
So for the last few days, we've been talking about rate of change or slope, and we've been looking at how to solve that both graphically and when given two different points. So I wanted to just kind of do a quick recap. So the slope we have now decided can be defined as many things, and how we try to identify the slope is going to change based on the type of information given. So in this example, I have a graph over here. So how I have typically found the slope in a graph is by finding the rise over the run. So if I select a given point on the graph, then I go up until I would meet even with the next point. So that was up 2. And then how many do I go over? I go over 1. So I'm basically building a staircase. I'm going up 2 over 1. And I can see that that happens repeating over and over again. And so we simplify this and say that the slope is 2. You could also do that by identifying the actual points and then using the slope formula, which is right here as y2 minus y1 divided by x2 minus x1. And given into an equation form, slope is simply m that's highlighted. M is also sometimes called a coefficient, a number in front of the x variable, or any variable for that matter. So a coefficient is the number in front of a variable, and they're multiplying together. That's m times x plus b. And then obviously we've also heard this as called the rate of change. So this is slope. It's going to give us the rate of change over time, how x, the function that's applied to x. So now let's take a look at what the y-intercept is. So if you look at the very bottom point here, we remember that it's the same equation, y equals mx plus b. B is my y-intercept. Sometimes it's also called where the line crosses the y-axis, and you can see where the line on that graph crosses the y-axis is highlighted in red. In terms of a scenario, it is sometimes referred to as the initial value, and that means it's also the value of y when x equals 0. B is sometimes referred to as a constant. A constant is a number that is just plain old number. There's no variable attached to it. It's not changing. That's why it's constant. It is the numerical value it is. So in this case, b equals 2 because that's where it crosses the y-axis. And so it is going to remain a constant 2. The y-intercept is not going to change in this situation. It always crosses at one exact location, and it's 2. So I've begun to discuss that equations, linear equations in particular that we're talking about right now, can be represented, and I've shown an example of how it can be represented in 4 different ways. So we can represent it using a graph, an equation, a table, or a scenario. So let's look at the graph first. We see here that we have a graph that is a straight line, okay, which means that it is a linear equation. That is our definition that we need for it to be a linear equation. And if we calculate, we can see that it crosses the y-axis at -3. Okay, so in other words, that's my b, my y-axis. And my slope we can find by identifying 2 points on the graph and then doing rise over run. So m in this case is equal to 3. Okay? So let's see if all of these match up. Well, if I look at my equation, I automatically see that it doesn't, because if my b is -3, that matches. But my m was 3, positive 3, which would leave it as 3x. Well, I don't want y to equal 3x minus 3. I wanted y to equal 2x minus 3. Let's see if the table or the scenario matches one of our previous ones. So in my table, remember, one of my definitions of the y-intercept was the value of y when x is 0. So here's when x is 0. So that means that this value right here is my y-intercept. Again, that's negative 3. Okay, well, what about my slope? Now, there's multiple ways we could figure this out. We could use the slope formula. Okay. We could also use looking at change in y divided by the change in x. So let's do it that way. So how is y changing to go from negative 1 to positive 1? Well, it has to go up 1 to get to 0, and then up another to get to 1. So it's going up by 2. And what about for my x values? To go from 1 to 2, it's just going up 1. So my change in y was 2 over my change in x. We can simplify that to just 2. So this is going to match with our equation over here because our y-intercept and now our slope as well are equal. All right, let's look at the scenarios, our last example. I owe my parents $3 and they have given me chores that can earn me $2 every week. So I always like to start with my y-intercept. In this case, the scenario, sometimes it's easier to think of it as the initial value. So what is my initial value? Well, it says that I owe my parents $3. So my initial value here is this. But is it positive 3? No, because if I owe someone money, then I have negative dollars available to me. I don't have $3 available. I owe it, so I have negative dollars. But luckily, they've given me chores that I can earn $2 every week. Okay? Pay attention to words like every or per. This is always going to give it away that that's the rate of change, or in this case, the slope. Okay, so here I have my slope is 2, and my y-intercept is negative 3. So all of these matched our equation here, except for our graph. It had the same y-intercept. The only difference was that it had a slope of 3 instead of 2. Now you're going to go and do your assignment, and you're going to do some discovery on how does changing the slope or the coefficient in front of x change how the graph looks? What about when you change that initial value or your b value, your y-intercept? How does that change the graph? And when you change these things, what stays the same if you only change one or the other? You're going to do some discovery, and I hope you learn a lot today. Good luck, y'all.